We go to subtopic 4.4, System of Linear Equations with 3 variables. Systems of linear equation. Consider the system of linear equation with 3 unknown x, y and z. 3x plus 2y minus z equals to 1, x minus y plus 2z equals to 5, and last we have 2x plus y minus 3z equals to 4. Okay, consider we have 3 system of linear equation yang ada unknown dia x, y and z. All the linear systems above can be written as a single matrix. So kita boleh tulis setiap tu sebagai bentuk matrik. Contohnya yang number tu kita let sebagai matrik A. So 3, 2, negative 1, 1, negative 1, 2, 2, 1, negative 3. Okay, kita consider this one as matrik A. Unknown yang kita ada x, y, z tu sebagai matrik X. So this one x, y, z. And selebihnya 1, 5, 4 sebagai matrik B. 1, 5, 4. The system of linear equation can be written as AX equals to B. So daripada sistem linear equation ni kita boleh tukar kepada AX equals to B. Cara dia, kita terus tulis 3, 2, negative 1, 1, negative 1, 2, 2, 1, negative 3. This one matrik A, AX, so matrik X is X, Y and Z, ada 3 unknown, equals to matrik B. Our matrik B is 1, 5, 4. Okay, macam ni pun kita boleh tulis. So AX equals to B. Okay, system of linear equation, this one can be solved by using inverse matrix, or we can use Cramer's rule. We go to the first method using the inverse matrix to solve AX equals to B. Inverse matrix, we have 2 methods. Either we use adjoint method or we use AB equals to KI. Okay, we look example number 1. Solve the following system of linear equations by using the inverse matrix. We have 3 linear equations. So, first step, we change this linear equation into matrix form. So, 3, 1, 2, 3, 2, 2, 1, 0, 1. Why I put this one equals to 0? Since this equation doesn't have x2. Okay, this one we let as matrix A. Then we have 3 unknown, x1, x2 and x3. So this one as matrix X equals to, we have number 11, 10 and 5. And this one as matrix B. We want to find matrix X, x1, x2, x3. So we need to eliminate matrix A first. Okay, to eliminate A, we need to times overall with A inverse. Then we expand. Okay, we know that A inverse times with matrix A, we can get identity. So I. Then we get X equals to A inverse times with matrix B. Okay, to find X, we need to find A inverse first. Okay, we have A. Matrix A is 3, 1, 2, 3, 2, 2 and 1, 0, 1. Okay, we find A inverse. Okay, to find A inverse, we have 2 methods. Either we use adjoint or we use AB equals to KI. But for this question, we can use AB equals to KI. So we use adjoint method. So formula for adjoint is 1 over determinant of A times with adjoint A. Okay, next we find determinant of A. Determinant is we choose any one row or any one column that easy to solve. So we take 1, 0, 1. And remember the sign for cofactor for third row. So positive, negative, positive. And put the minor. Okay, we close number 1. So we get 1, 2, 2, 2. We close 0, 3, 2, 3, 2. We close number 1, 3, 1, 3, 2. Then we solve. To solve minor, we use AD minus BC. So 2 minus 4 minus 0 plus with 6 minus 3. Then we solve, we get negative 2 plus 3, so equals to 1. So our determinant is 1. Okay, now we continue. We find adjoint A. To find adjoint A is cofactor transpose CT. Okay, CT, to find CT, we open big bracket. Okay, we put the sign and minor. Then we close every number. So we get 2201, 3211, 3210, 1201, 3211, 3110. Then next 1222, 3232, and last 3132. Okay, next we solve minor AD minus BC. So we get 2 minus 0, negative 3 minus 2, 0 minus 2, negative 1 minus 0, 3 minus 2, negative 0 minus 1, 2 minus 4, negative 6 minus 6, positive 6 minus 3. Okay, then we close, transpose. Okay, then we solve, we get 2, negative 1, negative 2, negative 1, 1, 1, negative 2, 0, and last 3. Then we transpose, we get 2, negative 1, negative 2, negative 1, 1, 1, negative 2, 0, and last 3. Okay, we substitute into formula. A inverse equals to 1 over determinant of A. Our determinant is 1. And adjoint is cofactor transpose. We get 2, negative 1, negative 2, negative 1, 1, 0, negative 2, 1, 3. Then we solve, then we get answer for inverse 2, negative 1, negative 2, negative 1, 1, 1, negative 2, 0, and 3. Okay. Actually, we want to find x. Okay, our x is A inverse times with B. Okay, we put A inverse 2, negative 1, negative 2, negative 1, 1, 0, negative 2, 1, 3. We times with matrix B, 11, 10, and 5. Okay, then we solve. Okay, we solve row column. 22 minus 10 minus 10, negative 11 plus 10 plus 0, negative 22 plus 10 plus 15. So we get 2, negative 1, and last 3. This one is x. Matrix x is x1, x2, and x3. Okay, jangan tinggal answer macam ni. Kita mesti keluarkan balik. Conclude x1 equals to 2, x2 equals to negative 1, and last x3 equals to 3. We continue question number 2. Given matrix A in 3 by 3 and matrix B also in 3 by 3. First, we find AB and then find A inverse. Hence, solve the following linear equation. Okay, first question, we want to find AB. Okay, so AB, we times with these two matrix. 1, 3, negative 9, 5, negative 1, 3, 1, 3, 7. We times with matrix B, 1, 3, 0, 2, negative 1, 3, negative 1, 0, 1. Okay, times, so row column. So we get 1 plus 6 plus 9, 3 minus 3 plus 0, 0 plus 9 minus 9, 5 minus 2 minus 3, 15 plus 1 plus 0, 0 minus 3 plus 3, 1 plus 6 minus 7, 3 minus 3 plus 0, 0 plus 9 plus 7. Then we solve, we get 16, 0, 0, 0, 16, 0, 0, 0, 16. So from this matrix, we can conclude this one as 16i. So we conclude AB equals to 16i. Okay, next question, we want to find A inverse. Since our previous answer is in AB equals to KI, so from this one, we can find A inverse. Okay, to find A inverse, kita gunakan balik je answer tadi, AB equals to 16i ni, dan darabkan semuanya dengan A inverse, since we want to find A inverse. So A inverse times with AB equals to 16A inverse I. This one becomes I, so B equals to 16A inverse. Then we get A inverse equals to 1 over 16 times with matrix B. Then we substitute matrix B. Matrix B is 1, 3, 0, 2, negative 1, 3, negative 1, 0, 1. Then we expand, we get 1 over 16, 3 over 16, 0, 1 over 8, negative 1 over 16, 3 over 16, and negative 1 over 16, 0, 1 over 16. So this one answer for A inverse. Okay, next. Hence, solve the following linear equation. So kita perlu solve pula linear equation ni. Cari value for x, y and z. Okay, first we change this linear in matrix form. So we get 1, 5, 1, 3, negative 1, 3, negative 9, 3, 7. Okay, times with unknown. Unknown is x, y and z equals to 7, 5 and 1. Okay, bila kita solve soalan matrik yang ada hence, kita kena check balik ada tak kaitan linear equation ni dengan matrik yang dia dah bagi. Okay, matrik A ataupun matrik B, ada tak kaitan dengan linear equation kita. So kita tengok balik 1, 5, 1, 3, negative 1, 3, negative 9, 3, 7. So ada dalam matrik A, cuma dia tak sama macam matrik A, dia ditransposkan. So means this one adalah A transpose. Matrik A kita ni, kita transposkan, kita akan dapat this one. So kita letak A transpose lah, bukan matrik A. Dia adalah matrik A transpose. This one X, and this one, since kita dah ada matrik B, saya tak guna huruf B dah, saya guna C. Tak apa boleh je. Saya tak letak B sebab tak nak bagi kamu confuse mana satu B. Okay, so saya letak C. Okay, sekarang ni kita nak find X. To find X, kita perlu hilangkan A transpose. So nak hilangkan A transpose, overall kita kena darabkan dengan A transpose inverse. So A transpose inverse, kita darabkan dengan A transpose, dia akan hilang lah, dapat I. So X equals to A transpose inverse C. Okay, then kena ingat balik dalam properties of inverse, kalau A transpose inverse, dia sama je dengan A inverse transpose. Okay, ni benda yang sama. A transpose inverse, dia same as A inverse transpose. Ini ada dalam properties of inverse. Boleh check balik nota yang lepas, properties of inverse. Okay, since kita dah ada dah A inverse, kita dah cari dah tadi A inverse. Sekarang kita nak A inverse to transpose. So kita transpose je lah answer daripada A inverse. So we get 1 over 16, 1 over 8, negative 1 over 16, 3 over 16, negative 1 over 16, 0, 0, 3 over 16 and 1 over 16. Okay, ini adalah A inverse transpose. Okay, kita times with C. Our C is 7, 5, 1. We times row column 7 over 16 plus 5 over 8 minus 1 over 16. 21 over 16 minus 5 over 16 plus 0. 0 plus 15 over 16 plus 1 over 16. Okay, then we calculate. We get 1, 1, 1. Then we conclude our X equals to 1, Y equals to 1, and also Z equals to 1. Okay, so we finish all the question in first method, inverse matrix. This question for your exercise. If you have any problem, you can ask your lecturer. Okay, so that's all for today. Thank you.